Viewers, you are welcome to this video. Today, I want us to look at what a solution to a differential equation is, or what is a solution of a differential equation. What is a solution of a differential equation? In my last video, I introduced you to differential equations. So those of you who have not watched that video, you are advised to go and watch that video before you look at this one. Yes, because you need to know what a differential equation is before you look at the solution of a differential equation. Now, the solution of a differential equation, or a solution of a differential equation, is a function that satisfies the differential equation identically. Again, a solution of a differential equation is a function that satisfies the differential equation identically. What this means is that when you solve the differential equation, you're able to get that function. And then you can also work on the function to get back the differential equation. That's why the word identically is there. Yes. So today I want us to look at this. You want to find out, so let's look at a question like this. Question number 1. You can give you a question like this. Is y equal to c1 cos x plus c2 sin x a solution of this differential equation d squared y dx squared plus y equal to 0? Yes. You can be given something like this. You can be given something like this. Is this one? Is it a solution of this differential equation? So let's look at it. Solution. Now, let's look at the function. This is the function they have been given. They are saying that is this one a solution of this differential equation? So this is the function. Y is equal to c1 cos x plus c2 sin x. And c1, c2 are arbitrary constants. They are arbitrary constants. Okay. Now, because this is the differential equation, then what you have to do is to find dy dx. And you see this one is the squared y dx squared. So you have to find dy dx. And then move ahead to find the squared y dx squared. Isn't it? So let me just do it here so that everybody can see. So this is the differential equation. So if you are finding dy dx, you are going to differentiate this one. Now when you differentiate cos, you get negative sign. Yes. So this one is going to be negative c1 sin x. Isn't it? Plus, now when you differentiate sin x, you are going to get cos x. So this one will be c2 cos x. So this is the first derivative. But because the equation is this one, the squared y dx squared, it means that I have to differentiate this one again. Now, the squared y dx squared, that is going to differentiate this one. This one is equal to, when you differentiate sine, you get cos. So this one will be negative c1 cos x. When you differentiate sine x, you get cos x. Now when you differentiate cos x, you're going to get negative sine x. So that one will affect this one, negative c2 sin x. Now look on the board. They have been asked to find out whether this one is a solution of this or not. Do you see it? So let's do the substitution. Now we have the squared y dx squared to be this, and then the y is this. So let's do the substitution here. If you do the substitution and you get 0, then you can confidently say that this one is a solution of this differential equation. So let's do the substitution. Now, so we're going to have this. So from the squared y dx squared plus y equal to 0, you can now say that the square y dx squared is the whole of this. So this one is equal to negative C1 cos x minus C2 sin x plus y. Don't forget y is this. Y is C1 cos x. C1 cos x plus C2 sin x. Yes, if you put these together and you get 0, then you can say that this one is the solution of this differential equation. Now let's check. This one is C1 cos x negative, and this one is C1 cos x positive. So this one will cancel this. Negative C2 sin x will also cancel positive C2 sin x. So this is equal to 0. Are you seeing it? And because I'm able to get 0, we can say that this one is a solution of this differential. So we can say therefore y equal to C1 cos x plus C2 sin x is a solution of b squared y dx squared plus y equal to 0. So this is how I have to conclude. So this is the solution of the differential equation. Are you seeing it? Yes, this is a solution. Now let's look at another question. Now you can also be given this. Let me clean the board. Question number 2. You can say that show whether y is equal to C1 sin 3x plus say C2 cos 3x is a solution of this differential equation y prime prime plus 9y is equal to 0 or not. So whether y equal to this is a solution of this differential equation or not. So if it is a solution, you see it's a solution. If it's not a solution, then you have to state it. Yes. Now let's look at it. So solution. Let's work it. So this is the function y is equal to C1 sin 3x plus C2 cos 3x. Now, this one means that I have to differentiate the function y twice. Yes, so let's differentiate the first time. So if you differentiate it, now look on the board. When you differentiate sine, you have to get, when you differentiate sine x, you get cos x. So if you differentiate sine 3x, you're going to get cos 3x times the derivative of 3x with respect to x. Yes. So this one is going to be C1 cos 3x times the derivative of this 3x with respect to x. And when you differentiate 3x with respect to x, you are going to get 3. So you are going to have 3C1 cos 3x. Now you see, when you are differentiating sine x, in the first question, sine x, you say you are going to get cos x times the derivative of x with respect to x, and that one will be 1. Because it is 1, that's why when it is sine x, you don't multiply by anything, because when you multiply by 1, you're going to get the same thing. Right, isn't it? So when it is like this, don't just say C1 cos 3x, that would be wrong. You have to multiply by the derivative of the 3x. Yes. So plus, now when you differentiate cos, you're going to get negative sign. Yes, when you differentiate cos x, you're going to get negative sine x. Which means that when you differentiate cos 3x, you're going to get negative sine 3x times the derivative of 3x with respect to x. So that will give us negative 3 C2 sine 3x. this one will be negative sine 3x times 3. So 3, negative 3 C2 sine 3x. So this is the first derivative. Now let's look at the second derivative. We are going to differentiate this one. Now, if you differentiate this one, we are going to get negative 3 sine 3x. This one. So the 3 will come and multiply this one. So it will be negative 9 C1 sine 3x. Because this one will come with a 3. Do you see it? Negative 3 sine 3x. When you differentiate cos 3x. So it will come and multiply this one. Negative 9 C1 sine 3x. Now when you come here, when you differentiate sine 3x, you are going to get 3 cos 3x. So if that one multiply this one, you get 9 C2 cos 3x. Are you seeing it? Now let's do the substitution. This is the equation you have been given. So let's do the substitution. So you can say that this is the differential equation. You can say that from y prime prime plus, let me just say from y prime prime plus 9y is equal to 0. You can say that y prime prime is the whole of it. So let me just write it. Negative 9 C1 sine 3x minus 9 C2 cos 3x plus, look at it, 9 times y. So this is the y. So we're going to multiply through by, we're going to multiply this one by 9, this one also by 9. So if you do that, we are going to get 9 C1 sine 3x, isn't it? Plus 9 C2 cos 3x. Now let's see if we can do some cancellations. Negative 9 C1 sine 3x will cancel positive 9 C1 sine 3x. Negative 9 C2 cos 3x will cancel positive. Negative 9 C2 cos 3x will cancel positive 9 C2 cos 3x. So the whole of it is equal to 0. And indeed, this is equal to 0. Are you seeing it? So therefore, we can confidently say that therefore y equal to C1 sine 3x, C1 sine 3x plus C2 cos 3x is a solution of the differential equation y prime prime plus 9y equal to 0. Yes, you can say that. This is a solution. Which means that when you solve this one, you are going to get this. Are you seeing it? And then when you can work on this one to get this. Now, before you look at the last question under this, let me explain one or two things. We have what we call general solution of a differential equation. General solution of a differential equation. And we have what we also call particular solution. Particular solution of a differential equation. Now, the general solution of a differential equation is the set of all solutions, or you can say it's a set of all solutions. Now look on the board. Look at this solution. Now you have seen that this one is a solution of this differential equation. We have C1 sine 3x, C2 cos 3x. This is a general solution. It's a general solution because these C1 and C2 are arbitrary constant. The general solution becomes a particular solution when we assign fixed values to the constants to determine whether y equal to this is a solution of this differential equation or not. Are you seeing it? So let's look at the solution. This is the last question under this. Okay. Now, this is y is equal to this. So let me write it. Y is equal to 2 exponential of negative x plus x. So to do some of these things, you need to really understand differentiation. Yes. So those of you who have not watched my video on differentiation, you can go and watch it. Yes. You can't do differential equations without knowing differentiation. You need to know all the rules. So that when you have any function, you know that, oh, this is how I have to differentiate it. Okay, that will be this way. Now, you have to differentiate this one once, and then differentiate it again. Now, look on the board. If you are differentiating this exponential function, you are going to get exponential of negative x times the derivative of negative x with respect to x. Are you seeing it? The derivative of this one. So the derivative of negative x with respect to x will be negative 1. So that will make this side negative 2e. So multiply it. Plus, now when you come here, you have to apply what you call the product rule. The product rule. So you can decide to differentiate this one, or you can decide to maintain the first one, differentiate the second one. So when you do that, look on the board. So I've maintained the first one, differentiating the second one. The second one, when you differentiate, I'm going to get negative exponential of negative x. Are you seeing it? Plus, this time, I'm going to differentiate the first one and maintain the second one, keep the second one constant. Are you seeing it? So if you differentiate x with respect to it, I'm going to get 1, and then I'll keep this one constant. That is the product rule. This is equal to negative 2 exponential of negative x minus x exponential of negative x plus exponential of negative x. Isn't it? Now this is equal to negative 2 exponential of negative x plus exponential of negative x will give us negative exponential of negative x minus x exponential of negative x, like this. Now, so this is the first derivative. And the differential equation has order 2. So we have to differentiate it again. So it means that y prime prime, we are going to differentiate this one. Now, when you're differentiating this exponential of negative x, you're going to get negative exponential of negative x. Don't forget. So that will make this one positive. So this one will be exponential of negative x. Because this one will come with a negative. It will be negative, and this one alone will come with negative, it's like this. Negative, then this one will be negative exponential of negative x. So negative, negative. That will be positive. That's why I have it. Now, if you look at this one, you have to apply the product rule. So this one, you are going to have negative. I can decide to differentiate the first one, maintain the second one, the product rule. So if you differentiate the first one with respect to x, you're going to get 1, maintain the second one. So that will give us this. Are you seeing it? But let me show everything so that everybody will understand. Exponential of negative x. Now, so I've differentiated the first one and maintained the second one. So I'm going to do the reverse. The reverse is this. Negative x, I'm maintaining the first one and differentiate the second one. If you differentiate the second one, I'm going to get negative exponential of negative x. So this is equal to exponential of negative x, negative exponential of negative x, negative, negative, positive x, exponential of negative x. Are you seeing it? Now look on the board. This will cancel this. This positive is negative, they will go. We are going to have x exponential of negative x. From this one, so we have y prime prime plus 2y prime plus y equal to 1. Let's do the substitution. Y prime prime is now this. So let me just put it here, exponential x exponential of negative x plus 2 times y prime. This is y prime. So times 2. So negative exponential of negative x minus x exponential of negative x plus y. Where is the y? This is y. 2 exponential of negative x plus x exponential of negative x. Are you seeing it? Now, if you're able to work on this and you get 1, then you can say that this is a solution of this. Otherwise, it's not a solution. We have an issue. So this is x exponential of negative x plus, now if you expand this, I'm going to get negative 2 exponential of negative x. Then this one will be negative 2x exponential of negative x plus 2 exponential of negative x plus x exponential of negative x. You have to be careful of the signs. So you have an issue. Now look on the board. X exponential of negative x and then x exponential, that will be 2x exponential of negative x positive. So they will cancel this negative 2x exponential of negative x. And then negative 2 exponential of negative x will cancel positive 2 exponential of negative x. So the whole of this is giving us 0. The whole of this is giving us 0. But look at what we are given. It said it should be equal to 1. And because this 0, so let me say the whole of this is equal to 0. And this 0 is not equal to 1. Therefore, we can say that y equal to 2 exponential of negative x plus x exponential of negative x is not a solution. It's not a solution. It's not a solution of the differential equation y prime prime plus 2y prime plus y equal to 1. Thank you very much for your attention. For more of this video, subscribe to my YouTube channel, Shamalaa Jnr.